Hey everybody, we're here with another contest question. So, this one came across my plate. Determine the number of perfect squares less than 10,000 that are divisible by 392. So, let's jump right in. Can you solve that problem on the screen? So, we'll go through a full detailed solution to it, see what you came up with. Here we go. Okay, so determine the number of perfect squares less than 10,000 that are divisible by 392. So the first thing that I would maybe draw your attention to is if something is going to be divisible by 392, then that means 392 has to be a factor of it. So if I wanted to see what numbers, just in general, are divisible by 392, then I have to make sure that they have all the same factors of 392. So what I'm going to do is I'm going to take 392 and I'm just going to factor it out. I'm going to do a little factor tree. So 392 is even, so I at least know that 2 goes in. And if I divide 392 by 2, then I'm going to get 196. Okay, now I could factor that 196 and say, hey, that's like a 14 and a 14 because I know that perfect square. But I might even stop. Like I might stop at the 196 because it is a perfect square. And the only reason I'm stopping my factor tree is because the problem is asking me for perfect squares. So I'm going to leave that 14 times 14 on, just so we can remember that a little bit. Okay, if something is going to be divisible by 392, then it has to have the factors of 392 in it. So that means that we need to have a 2 and 2 14s. Now, because I'm looking for perfect squares, the 2 14s are great. That's what I want. My problem becomes this lowly 2 that's still sitting there. What that tells me is 392 is not a perfect square because I don't have 2 of the same factor. So if I wanted to make a perfect square, what I need to do is I need to take that lowly 2 that I have as its extra that doesn't have a pair, and I need to put another 2 in there. What you'll notice now is I have 2 of the same factor of everything. I got 2 14s and I have 2 2s. So if I calculate that new value, then I'm going to take 392, that's what that orange was, and I'm going to double it. And that gives me a value of 784. Okay, I know now that if I divide by 784, I'm dividing by a perfect square. 784 is a perfect square. Like, if we care enough, we can see it's 28 times 28. That's not needed for the problem, though. But it is important for me to know that it is a perfect square. It's also important for me to know that it is divisible by 392. It goes in twice. Okay, why did I do that? Well, I'm going to get rid of some of my extra little notation there. It's because what I could do now is I could build, hey, how many numbers could I create that were perfect squares? So maybe what I do is I build a list. So what I'm going to do is I'm going to hop up on that right corner and I'm just going to build a list. Right now, if I was to go through and say, I'm going to take that 784 and I'm going to find another multiple of 784. Well then, I could multiply by 2 or I could multiply by 3. But I don't care about multiples of 784 if they're not perfect squares. Remember, I'm looking for perfect squares. So what I would want to multiply by would be another perfect square. I want to put in 2 of the same factor. So if I multiplied by 4, I'm hoping that we can see that I would create another perfect square. 784 is a perfect square, 4 is a perfect square, so I know I will have two of the same factor. Now, if I do a little calculation, my 4 times my 784 is 3,136, and I just found another perfect square that is less than 10,000, and it is divisible by 392. Okay, well, keep building your list. Well, maybe I start with that 784, and then what I'm going to do is I'm going to multiply by another perfect square, 9. There's my 3 times 3, putting in two of the same factor. That would get me 7,056, another number less than 10,000. And I could continue on building up. Well, my next two of the same factors would be 4 times 4. If I multiply that, then I get a 12,544. And I've hit a value that's greater than 10,000. So I cannot include the 784 times my 16. So what I did was I just went through and I built a list of the possible factors that I knew were perfect squares and divisible by 392. Okay, well, what is that list? Well, at the very end then, I could say, well, I know that 784 is divisible by 392 and a perfect square and less than 10,000. And I had 3,136, and if I just move that over a little bit, 7,056. So I have 3 perfect squares that satisfy that problem. Okay, now make a note, though, that the question said determine the number of perfect squares less than 10,000. It doesn't ask you to determine what they are. So I didn't really need to come up with that orange list, although it allows me to answer the question, therefore 3. I have 3 perfect squares less than 10,000 that are divisible by 392. Okay, there's one way that you could play through. I want to show you an alternate way, and it's just a way where I don't really have to come up with the specific values. It's a way I could answer the question, and I could argue in a more efficient way. Since I don't need to know what the actual numbers are, I could have, once I found 784 as a perfect square, divisible by 392 and less than 10,000, I could have then said, okay, wait a second. Let me take that and just come down here. If I now calculated 10,000 and I divide it by 784, then I can figure out, okay, well, how many times does 784 divide into 10,000? And when I do that, I'm going to get an approximate value of 12.76, and it's 755, blah, 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 but I really don't need that detail. What I can see then is the biggest factor that I could multiply, or biggest number that I could multiply 784 by, and still come in short of 10,000, would be 12. If I was to multiply by a number bigger than 12, like 13, an integer, a whole number, bigger than 12, that's going to put me above 10,000. So what I saw with that 12 is it kind of gives me my wiggle room. That's my limitation. And so instead, what I could think of is, well, if I need to put 2 of the same factor in there, therefore perfect squares, then there are only 2 perfect squares that are less than 12 that are going to give me a different value. So right there, I could go, I know that I only have 2 values. If you're looking at it and you're thinking, well, my 2 values less would be 4 and a 9. I could multiply 784 by 4, I could multiply it by 9, and I don't need to confirm that those values are less than 10,000. I know that they will be. So as long as I tie that back together with the 784, then I could come to that conclusion that there are 3 values to that problem without ever actually calculating what those values are. Okay, I really like that problem. And I'm hoping that that solution gives you a rundown, not just in what the answer is, but why. Okay, keep plugging through with your contest problems. You're doing great. Best of luck.